today we're going to be talking about texture and displacement mapping workflows within 3D printing. And let's just hop right into it. You know, I am just going to kind of preface this with some kind of base material here and some examples. And what I want to say is, you know, CATI, we're a long-standing partner of Stratasys, and Stratasys makes the most capable color 3D printers that you can have today for hyper-realistic product development. There are certainly other color 3D printing technologies, and these workflows should apply to the whole gamut of technologies out there. So we are talking a little bit broadly, but we will kind of dial into some specific aspects of the Stratasys 3D printing workflow. But you know, I really encourage you to reach out to me afterwards if you have any follow-up questions. We're going to kind of start at a high level and kind of make our way down to a much closer view. But, you know, like anything, a 3D printing workflow may be very specific to you or your organization, and we want to help you find the right solution that fits. So I do have just some examples here, some of these which you may have seen through Stratasys marketing or through CATI, and then some of these are just my own personal examples that I threw in here. Main point being is that color 3D printing has an impact on product development by allowing a way to create and envision your end result before you manufacture anything. So whether it is you know, a packaging solution or a product itself, or maybe it's just a visual display model that's used for communication, there's a whole multitude of really high fidelity solutions that we can create using the Stratasys PolyJet J series printers. Now, I'm the kind of person that I'd rather show you how to do something than just talk about it. And so what I did is I took a lot of the methodologies that are going to be included in this presentation, and I just packaged them up into a project that I did. And so this is just a very quick overview, before kind of a preview, if you will, of what we'll be getting into. I have a lot of kind of click follow tutorials at the end that are really just meant to show you how these tools work. And so what I did is I designed a mallet, a shop tool, which is a great industrial design exercise. And I brought it into a bunch of different texture and displacement mapping softwares. I kind of made quite an elaborate workflow. I wouldn't expect that yours would be this complicated, but maybe it will, depending on really what your project needs are. So we'll outline a range of software solutions, and you know, I did this project within a 24-hour period of time from designing it to coming into work the next morning and taking it off the build bed and giving it a little bit of a polish so it looks nice and pretty. So that's kind of where we're going to go. So let's go into it. Starting with the basics, I did want to cover just how the technology works, right? So PolyJet is a photopolymer jetting technology that uses a photoreactive resin that gets selectively deposited one layer at a time. And very similar to a 2D color printer, we have these droplets that are actually going to be volumetric droplets. So they're not going to be pixels, they're going to be voxels. And with each layer, it lays down the cross-sectional profile of your part and then cures it with UV light to become solid. And we have a range of materials to pick from that get mixed together in a grid-like pattern or in kind of a matrix. And then there's also a support material. Ink jetting is a very scalable technology with very high throughput. So we're able to print a large object faster than any technology in additive manufacturing that requires single tool paths. And that is because we have these inkjet heads that have 192 holes. They're about 50 micron size, and we're depositing material in these kind of linear x-axis movements. So it's a very good technology for doing a lot of parts quickly. And here's just what the PolyJet product lineup looks like. The J-series machines are really kind of where we see these full color solutions coming into play. It's certainly the most impressive out there in terms of color, material selection, and vividness. We have a range of materials to select from. Today, we're really going to be focusing on the capabilities using the Vero materials, which is our rigid base color line of materials. But then there's a bunch of other ones that are flexible or have special properties. Maybe it's for the medical or dental market, or are application specific related to some of their temperature properties. And to just, give you an overview of kind of how the workflow as most people see it, just to cover this, I mean, I'm sure you've seen similar slides within 3D printing that show this workflow, where we start within our CAD suite, and then we're going to have this file handoff into our slicing software. And in the Stratasys world, it's going to be GrabCAD Print. That's our slicer. And GrabCAD Print accepts a range of files from mesh type formats like STL, OBJ, Vermal. There's parametric files like STEP and IGES and Parasolid, and even native formats like a SolidWorks file or an Inventor file or a Creo file. All of these things are imported into our slicing software and then queued up and sent to the printer. So just to have a little bit of a baseline idea of kind of two different versions of the workflow, of what we could be doing. In one instance, we can print an image that is wrapped around in a mesh, and that's going to be an OBJ or a VRML format. And then on the other side, we're going to have kind of single shells as an STL or maybe even a native format that we can apply color to within our slicing software. So here's a look at those two different workflows. So starting with this, I just have this little bracket component, and I decided I wanted to just grab some textures from the internet and throw it on that part. And so I was like, you know what, I'll do a little digital camo. Well, I decided to make it fun. We'll do pink digital camo. And I found a texture that I liked that was at a high resolution. I saved it, renamed it. It's always really important to have good file naming conventions. And then I just grabbed my part and I applied it using this software. This is actually Materialized Magics. And there's a lot of softwares that can actually do what I'm showing you here. This is just one that was available for me, and I'll detail more softwares later on that you can also do these same workflows in. And so I applied my texture and I save it out as an OBJ file. And then from there, I just verify that everything looks good when I bring it into GrabCAD Print onto our build platform. So there you can see it's a very simple workflow, and here my part is on our build platform. So in contrast to that, I'm going to show you just bringing in multiple STL assembly that I'll assign colors to individually in GrabCAD Print. So here there is no color assigned to my model when I save it out, and when I bring it into GrabCAD, I'll import all the files as an assembly. There's my last version, and here I add STLs as assembly. Select my files, all three of them, and they import. I'm just going to reorient this part, and here I can just toggle having them selected or deselected. I usually have them unassembled when I'm designating color. And so I just pick from my color sliders here the individual colors that I want. And when it's all said and done, I could just toggle my little assembly checkbox. So two methodologies, two methods for assigning color. Now this is just very simple. As we go on, we're going to add complexity to this process. And just a little bit of color theory here. You know, there are different color gamuts, and the color gamut that your eyes can see is known as the Levy gamut, and that's everything that the eye can perceive. There's also the RGB gamut, that is what your computer monitor or digital monitors will display, and it's you know, a section of the LAB gamut. There's also the CMYK gamut, that's what 2D printers use, and it has kind of its range of capable colors associated with it. And then there's also Pantone, which is designer colors, a very popular kind of guide or category of colors. And then in yellow here, you can see this is the J750, this is the J7 series color gamut. And you know, this is something that we want to expand and has been expanding since the release of this printer. And so as you can see, we have this overlap into kind of all these different color gamuts. Pantone, as I mentioned, is very popular within the design community, and this is a very design-focused product. And so there was a demand from the market to have support to print Pantone colors, which came out about a year ago. And if you have a J7 series, here's just a couple things to enable that. One, you want to make sure that you're performing the right amount of printer upkeep. So check your maintenance counter and see that you're doing all of your tests in the right amount of time. You know, you don't want your machine to kind of fall out of maintenance. And then from a software standpoint, you just want to make sure that these base materials are loaded, and that's going to be Vero Black, Vero Pure White, Vero Cyan, Yellow, Magenta, the vivid version. So the Vero colors have the Vero Vivid colors, which allow you to print much more, get vivid tones. And once you have all those things enabled, there should be a little Pantone swatch within GrabCAD Print that you can search by hex code or RGB code or Pantone number from the Pantone matching system. And it will give you a little indicator saying that printed is an accurate match, or maybe there might be some visible differences, or maybe it's not so good of a match. So just a little exercise to show you how it's done. I have this assembly of files here, and I'm going to bring it into GrabCAD as an assembly, select my files. And in the same way as I showed before, I can assign these Pantone colors by just searching for them and applying them to the model. And this is a really good solution for the packaging industry and consumer packaged goods because everyone wants to print something with their brand colors. Okay, so simple enough. Let's move on. Now, showing color on a screen, obviously there's a little bit of a discrepancy there, right? Because our screens are going to show us everything in RGB, and what we print is kind of like a modified version of CMYK. And in the 2D printing world, it's always really important to do hard proofing. That's when you're going to print something out and look at it and ask yourself, is this the right color? So this is a little exercise I put myself through using a utility that's built into GrabCAD Print that allows you to generate a swatch of very similar colors. So I chose the Mira Verde, which is the color of my favorite car, the Lamborghini Mira. And I just Googled the hex code for it. It was available on the internet. I plugged it into the swatch generator, and it printed it out. And then what I was able to do is to kind of hard verify against my sample that this was the right color. So let's kind of get into some of the more complex concepts that are involved in these workflows. So when we're doing shell-based color parts, it's very simple because we can move directly from our CAD suite into our slicer and then send to the printer. But if we're doing something like these shifter knobs that are really high fidelity piece that you may have seen printed at trade shows, there's a little bit of an amendment made to this workflow that involves applying a texture to a mesh geometry in another software. And perhaps the software that you're working in today offers that functionality. Perhaps it doesn't, and you want to find a way to do that. And so you're going to do that before you bring it into your slicer, and I'm going to show you how to do that. To understand a little bit why your current CAD program may or may not do this, well, it kind of fundamentally relates to the type of mathematics that drives our CAD software. So a lot of our customers are using SolidWorks today, and we are one of the premier distributors of SolidWorks and SolidWorks products. And similarly, a lot of other solid feature-based modeling CAD suites may not have a lot of tools that can be translated into color 3D printing. Now, there's also NURBS modeling, and then there's also polygon modeling, which is sometimes called direct modeling. And these are more native mesh-based CAD modeling softwares that are used in computer graphics and the gaming industry. And they have a lot of these tools that are used for doing texture and displacement mapping. So the question is, why can't I just export from one of these programs into another? And there are some methods to do that. There's no cure-all solution for this file exchange, and it really relates to fundamentally how the CAD data is generated. And in a solid modeling environment, when we're exporting a mesh, it's going to create a polygon model. And you know this if you've worked with STL files. Well, in a direct modeling environment where they're doing a lot of these color mapping, texture mapping workflows, they're modeling with quads, a quad-based mesh, which is really hard to translate these polygons into quads. You can go from quads to polygons very easy, but it's not really backwards compatible. And why these direct modeling softwares are using quads is because of this workflow called UV mapping. UV mapping is basically this concept of unwrapping your model, laying it flat, and then projecting an image to that flat plane. And it's called UV mapping because UV denotes a coordinate system in 2D space for a 3D model that's laid flat, and X, Y, and Z is already in use, so they started using the letters U and V. So there's a lot of different types of UV mapping, and we're actually using two specific types of UV mapping in our workflow. We're using texture mapping, which is the 2D appearance that's on top of your model, and then there is displacement mapping, which is the 3D appearance on your model. Now, sometimes you might hear people talk about bump mapping or something like that. Just know that that's commonly used. That's a common misnomer, and when people are referring to displacement mapping. And there's these other UV mapping techniques that are used in rendering that are not really relevant to us in 3D printing. So in texture mapping, as I said, that is unwrapping our model, and we're applying a 2D image to it. That is not going to change anything about our geometry of the model. Whereas in displacement mapping, we're starting with a base geometry and we're adding we're adding some sort of texture to it, some physical texture that is going to actually alter the 3D geometry. So what softwares should you use? I get asked this a lot. Here's just a few that I've used in the past. You know, I don't think that there's really any single solution that, you know, I would say is the best, other than there are particular ones that are, you know, it's all about using the right tool for the job. And that might be related to the functionality and the cost in many ways. So I would also say, you know, do a little bit of research and take a look. Some of these are very easy to use. Some of them are more complex. I would say that the cheaper ones are going to require the greatest amount of time input to learn, where the ones that are more of an investment typically are more turnkey. And so that's kind of the cost time benefit in doing these. So I will say also that, you know, SolidWorks Visualize is really good for texture mapping, and SolidWorks natively does have some displacement mapping tools in there that came out about a year ago. So I should add a little blue star next to that. So in summary, UV mapping, really easy to do with quads, not so easy to do with polygons, but it is possible, and we're doing texture and displacement mapping. So when we do UV mapping, there's a couple core ways to really approach how we're going to be projecting an image onto our geometry. There is planar mapping, and that is really just taking a plane image and pushing it across a part. There is box mapping, which is going to handle your geometry as if it was a cube and project your images as it would project onto a cube. There is spherical mapping and cylindrical mapping, which is also just based on you know, prismatic geometry types. Then there is custom UV mapping, where you're going to selectively choose where all of the seams of your part are, so that you can get the greatest amount of control. And I would say that if you have a very complex object, like a figure, like something you know, that is a very organic geometry, custom UV mapping is going to benefit you the greatest. Whereas if I have something that, you know, is generally a really simple object, I can use one of these prismatic styles, and I can save a lot of time. So you know, I'm gonna cover a lot of these. So we have some videos. If you have any questions from the videos, you know, be sure to ask in the chat window. I'll keep an eye on that, and we can always, if I miss anything, we can come back around towards the end. So this is planar mapping that I use Materialize Magics, which we are also a partner of Materialize. And so if you have questions about this software as it relates to, you know, a 3D printing file utility, I can help you out with that. So I bring in my file. I actually had it broken up into separate shells. And here's the mallet, and I'm going to select that shell. And I have a pattern that I downloaded from the web that I'll apply. And as you can see, the triangles are a little bit wonky. It's kind of tessellated in this kind of non-uniform way. It always helps when you have a 3D mesh that is, I guess, has isometric triangles on it, or, you know, homogenized triangles, so that everything is the same size. And as you can see, as I'm applying this texture, it's kind of got some banding on it, but I can finesse it in a way where it looks even. So here I have kind of this little rubber texture, and it's a part of my assembly. So very easy using Materialize Magics. In another way of doing it would be a custom mapping using Photoshop. Photoshop is you know, a classic 2D design tool that has 3D utilities built into it that make it a usable tool in our workflow. Here, I just drag and drop my geometry in. And as you can see, you know, I'm having this weird tessellation going on. So what I'm going to do is I'm going to remesh my part so that that map is redistributed. It's still not perfect, again, because we're using triangles, but it still allows me to get the job done. And I define my texture here, and I have a pattern that's very repeatable. And I overlay that, and when I go back to my model, it's been auto-populated. And from there, I can save it out and bring it back into my assembly. So SolidWorks, as I said, has some UV mapping capabilities as well. It's in a plugin called SolidWorks Visualize, which if you are running SolidWorks, I think it's either Essential or Premium, it should have this built in. You can just go into your add-ins tab and see if it's in there. And so here I have this little handle of my mallet that I designed, and it brings it in here, and I can either choose from their library of appearances, or I can create a custom one of my own. And so I already had this little library set up for the demo, but I really wanted to get a good carbon fiber texture. So, you know, I'm just pulling it from the internet. You know, if you're in a design department, you might want to build up a library of your own that are relevant to the products that you build. And I've just patterned this, this texture and applied it. And there's different, I can also toggle the type of projection that we were talking about before. I think right now I'm projecting it as a cylindrical projection. And you can see that these different projection modes are going to have different effects on the quality of the texture. So here you can see that, I think I selected box mapping, and that looks really good. And then I'll just save it out. Very easy. And here's another program that I used, and here this is more explicit custom UV mapping where I'm selecting my seams of my part. So I said I want to handle this geometry in a very specific way because, you know, it's going to be maybe, you know, produced in a way that might have these seams, or maybe this is just more appropriate for my geometry. This program 3D Code is a low-cost tool that I just, you know, I identified this just to show that there are a lot of programs out there that you can do this with. So here I've kind of isolated my side A and side B along with these top cap layers, and now I can apply my texture by importing it. Yeah. Skip forward here. There we go. So I've applied my texture, and as you can see, it's mapped really nicely, but we have those seams on the side, and that might be preferable depending on what type of a texture you're working with. And then from there, we'll just export the part. All right, so moving along. The last thing that I want to show is about displacement mapping. Displacement mapping is going to be the physical texture. Where you might want to create a bumpy surface, you know, mimicking some sort of pattern. You know, this is something that is really key when you want to get that hyper realism, that real that tactile feel of something. And it could be wood grain, it could be leather, it could be some sort of knurled surface. So here I'm bringing in the bottom of the mallet, and I'll import that. I imported it as a parasolid into Rhino. Rhino is another NURBS modeling program. And here they have some displacement mapping tools where I've imported a bitmap image that is projected onto my geometry. Now, the success of this may sometimes be related to the density of your mesh, and that's why I'm working with a parasolid right now, because I can apply it without dealing with a really high polygon mesh. And now I'm just kind of defining my bump sizes, and I'm patterning it around my model. And I'm going to multiply that. I'm going to adjust the distance from them. So now you can see that it's kind of embedded into this model. And my last step after I apply this is to triangulate my model and export that mesh. And you can see it's a very high polygon mesh. So keep in mind that when you do this workflow that you will be doing data intensive processes. So I would recommend doing it on a system that has a good amount of RAM is really key in doing some of this. And so I saved that out. So that's kind of the bulk of it. I did add a couple other things that you should be asking yourself as you do these workflows. One of them is about how PolyJet handles color and texture. So there's a 3mm skin of color before it gets to the core of the model, and then it'll fill the interior with a base color. Since the Vero, cyan, magenta, and yellow are semi-transparent, you want to have a model that's going to be thick enough so that light does not permeate through it. Another thing to consider is handling textures that are built from images and imagery that is tileable. So if you're selecting an image that has kind of a gradient effect to it, it's not going to want to tile in a way that it looks realistic. And so here in this video, I'm just kind of showing the differences between what a good texture looks like and what a bad texture looks like. Let me skip ahead here so we can, you don't need to see me poking around on Google Images. So here's an example of a really bad texture. It has this spotlight on it and these gradients. So when we bring it into Photoshop and make our textures, one is going to tile and pattern really nicely, while the other one does not. So you can see a really jagged line. It's not going to be repeatable. Whereas the other one, when we pattern it, it's going to look really nice. Okay. Cool. The next thing to consider is for someone that is going to have a need for a very high quality, high accuracy color realism 3D print. And so this is for any of y'all that are doing wood or doing textures that relate to your final printed or your final manufactured product. And you know that pixel to pixel, you need to maintain the highest amount of color accuracy. So in this example here, we're taking this wood, and they really want the wood to look exactly as it was in the original sample imagery. I'm going to load it into Photoshop using the J-series color gamut. So it'll show us what colors are within gamut and are out of gamut. So here we can toggle on which pixels are capable of being printed and which pixels are not. And so the ones that are not become gray. And what we can do is we can filter these images using the tools that we have in Photoshop to eliminate all of those out of gamut textures and pixels and move them to the closest color that is within gamut. And so this is a color matching workflow that I borrowed from the 2D printing world. And typically when they go and hard proof anything that gets 2D printed, it's a very similar workflow from what I'm showing here. Generally, you want to bump up your exposure, your offset, and your gamma correction as much as you can. And then also adjust your lightness and print out multiple samples of it. And if it's too vivid, you just back down the lightness until a point where you feel like it's the closest that it can be. So it is a little bit of a back and forth process. And this is really for people that need the highest amount of color accuracy possible. And, you know, I just created some questions that people should be asking themselves when they implement these workflows, like what level of texture realism do you need? Are you creating something that is more of a concept visualization, or are you doing something that is going into the hands of people for, you know, market research, right? Are you doing a focus group? You can get to 80% realism very, very quickly, but it could be those last couple percentages of realism that you might spend a lot of time figuring out. And so ask yourself, what is the deliverable that I need for this 3D print? Think about what surfaces are most important. Focus on your A-facing surfaces. If you have a texture that doesn't line up perfectly on the interior of your model where no one is ever going to be looking, I wouldn't spend time on it because it's not going to be important. Is there anything that you can do to simplify the model? Obviously, prismatic geometries are much easier than something that has complex contours. Fillets are one thing in CAD modeling softwares that don't necessarily tessellate very accurately. So if you can eliminate those fillets and then just sand them down afterwards, that's a workflow efficiency. And then think about what are the best methods of projecting a 2D image onto a 3D object. If it's spherical, use sphere mapping. If it's a box-like object, use box mapping. Think about where your parting lines and seam lines are, because if your textures mimic that, it actually is a bonus. And the last thing is just about designing a part appropriately. We're all CAD users, and I know from personal experience, I'll make something quickly, but did I do it the right way? Am I using the right tools to get it done? Sometimes the answer to that is no. And when you go and tessellate an object, when you export it as a mesh file, sometimes those flaws that you overlooked from a visual standpoint will be reflected in the actual mesh that you're going to be using for displacement or texture mapping. So, you know, ask yourself these questions anytime you do one of these projects. And that brings us to the end. Again, you know, reach out to me. A lot of I'm seeing some questions here. So thank you very much, and I'm going to go through them in a second. And perhaps some of these questions might require a little bit of tech dev, as any workflow out there is going to be specific to your needs. So thank you, and let me run through some of these questions. Let's see. Is there a way to isolate specific regions on a grip to apply displacement mapping? Yeah, that's certainly a challenge. I think that it depends on what the contour is. I've done stuff in the past where I use a tool like Magix, like Materialized Magix, and there are certainly other there are certainly other options out there that for handling mesh where I selected a region, not triangle by triangle, but I kind of selected by a seam, kind of like what I was showing in the 3D coat tutorial, where you can select a specific area that you can isolate. And I've done that by basically selecting that area and saving that out as a surface, and then bringing it in as a separate file. What does get tricky about that is maintaining its positioning in the global coordinate system. So when you bring everything back together, that it's all in the same place. So to answer, yes, there is a way. It is a little bit more involved. So Mark asks how to take FEA colors and apply it to a 3D printed part. It's a good question, and it certainly depends on the FEA software that you're using. I've done tests in various softwares, and typically one of the problems that you'll run up against is that while it'll, depending on the FEA package, it may or may not want to export the color data with the model. I think that if there is a specific package that you're using, then what I would do is I would look at the different types of files that it can export and test exporting each one of those to see if it will associate those color types, and if it doesn't, you may not be able to, depending on some of the CAD packages. I have run into that in the past, but reach out to me and we can discuss it, because I may be able to find some workarounds for you.
Can I add something to that, Danny?
Yeah, absolutely.
So I believe, I have most experience with SolidWorks, and SolidWorks is able to export a vermal depending on the mesher that you're using, or the way that you set up the mesh. Not all of them work with it. And then aside from that, you can also set up ISO clipping. So you set up a range of your results, and you can clip your model, and you can export those separately and then assemble them back to GrabCAD Print, and then assign the colors manually. It's a little bit more in depth that way, but there's two different methods that I've tried and have good success with. Awesome.
Yeah, you'll have to show me that. I know that SolidWorks has some turnkey tools, yeah, that's a really good workflow. So thank you. Let's see. Specifying color for translucent parts with clear and vivid colors. Thank you for asking this, and certainly reach out to me, because that section did not make it in here. Within your CAD package, some of them have an option to export as a transparent material, and some of them don't. I know that a lot of the direct modeling suites, you can assign an object as an OBJ file. You can export associated as a clear material. I know that Rhino does it as well. I'm going to have to check back to see if SolidWorks will do it. But I have some links to tutorials online that was done by our friends over at GrabCAD that specifically show you how to do that. So please send me an email, and I will forward you those tutorial links.
Doesn't Stratasys have something like the advanced slicer for the J7, J8 series? Does that ring a bell?
Yeah. So that is going to be from an importing and printing standpoint. So the advanced slicer on GrabCAD Print is what you're going to need to have enabled in order to print the clear with color. When you export an OBJ file, if you were to open it in a program like Notepad or text editor, there's basically a little within the language, it basically just says material, and it's a 0 or 1. And some of the exporting utilities have that ability to toggle it, and some of them don't. So, you know, while there are some CAD packages that won't allow you to do that in the UI interface, you can also manually edit it so that it imports transparent. So, see here. And topologies, you know, I'm familiar with it, but they're not one of our partners today, so I can't really speak to it. And Keyshot to capture and apply texture displacement mapping. Yeah, absolutely. Yeah, Keyshot definitely has some good texture and displacement tools in there. And if you're a Keyshot user, definitely play around with them and try bringing them into GrabCAD Print. GrabCAD Print is free to download. I've not used Keyshot since it was Bunk Speed Shot as a plugin for SolidWorks. So you probably know way more about that software than I do. But like I said, GrabCAD Print is free to download and play around with. So what I would recommend doing is download it and go through kind of a test workflow and see if it's going to translate well. So let's see here. It is 1:50. If anyone has any other questions, let me know. And if not, again, thank you very much for joining us today.